Hi, Assalamualaikum and good day. Today we are going to learn on integration by parts. This is the objective of our lesson. By the end of this session, you should be able to solve integral using the technique of integration by parts. Following is the formula for integration by part, which is integrate u dv. The answer is uv minus integrate v du. This formula is obtained from the product rule of differentiation as given below. The main goal in integration by part is to choose u and dv to obtain a new integral that is easier to evaluate than the original form. When you apply integration by parts, first thing you need to do is to choose the correct u and dv. If you choose the wrong one, you will obtain a complicated integral which become more difficult to integrate. When choosing u and dv, we can use a method called LIATE. LIATE here stands for logarithmic, inverse trigonometrics, algebraic, trigonometrics, and exponential function. U is choose based on which of these functions come first. Let's see how it's worked by finding u and dv for the following integrals. The first integral consists of two functions. X is an algebraic function, or A. Exponent x is an exponential function, or E. From LIATE, as A comes first, we take u as x and dv as exponent x dx. The second integral consists of A and L. As L comes first, we take u as ln x and dv as x dx. Take note that dv must always have dx in the answer. The third and the fourth integral consist of a and t. From LIATE, a comes first. Therefore, u is equal to x for both integrals, and dv is equal to sin x dx for the third integral, and dv equal to cos x dx for the fourth integral. The fifth and the sixth integral consist of e and t. From LIATE, t comes first. Therefore, u is equal to sin x and dv equal to exponent x dx for the fifth integral, and u equal to cos x and dv equal to exponent x dx for the sixth integral. As for the last two integrals, they consist of only one function, which is I. As we need to have two functions for us to compare, we need to assume there is one more function, which is 1. As 1 is referred to an algebraic function, these two integrals consist of A and I. From LIATE, I comes first. Therefore, u is equal to the arctangent x and dv is equal to dx for the seventh integral. And for the last integral, u is equal to the arcsine and dv is equal to dx. Now, let's do the following example. To solve the integral using integration by parts, you need to follow the following steps. Number 1, choose the correct u and dv based on LIATE. 2, differentiate the u. 3, integrate the v. 4, substitute the information into the formula of integration by parts. And the last step, simplify and solve the new integral. For example 1a, you need to integrate x exponent x dx. The integral consists of a and e. As a comes first, u in this integral is referred to x and dv is equal to exponent x dx. Integrate u with respect to x, the answer is 1, and integrate v, the answer is exponent x. Substitute this accordingly into the formula, you will obtain x multiplied with exponent x minus the integration of exponent x dx. Simplify and integrate the new integral, you will obtain x exponent x minus exponent x, then plus with c. Let's proceed with example 1b. You need to integrate x ln x dx. Here, the integral consists of a and l. From Liate, l come first. Therefore, u is equal to ln x and dv is equal to x dx. Differentiate u with respect to x, the answer is 1 over x, and integrate v, the answer is x squared over 2. Substitute the answer accordingly into the formula, you will obtain ln x multiplied with x squared over 2 minus the integration of x squared over 2 multiplied with 1 over x dx. Simplify, you will obtain x squared over 2 ln x minus 1 over 2 integrate x dx. Integrate x with respect to x, the answer is x squared over 2. Simplify the whole answer, you will obtain 1 over 2 x squared ln x minus 1 over 4 x squared plus c as the final answer. For example 1c, you need to integrate the arctangent of x with respect to x. As the integral consists of only one function, which is I, we need to assume there is another function which is 1. As 1 is referred to a, this integral consists of a and I. From Liate, I come first. Therefore, u is equal to the arctangent of x and dv is equal to 1 dx. Differentiate u with respect to x here means you need to differentiate the arctangent of x. The answer should be 1 over 1 plus x squared. You can refer to the list of standard formula in the earlier page of the notes. Integrate v, you should get x as the answer. Substitute accordingly into the formula, you should get the arctangent of x multiplied with x minus the integration of x multiplied with 1 over 1 plus x squared dx. Simplify, you will get x, the arctangent x minus the integration of x over 1 plus x squared dx. To solve the new integral, you need to apply the u substitution. By letting u equal to 1 plus x squared, differentiate the u with respect to x, the answer is 2x. Substitute this back into the integral and simplify, you should get 1 over 2 ln 1 plus x squared as the answer. Therefore, the final answer is given by x, the arctangent x minus 1 over 2 ln 1 plus x squared plus c. Now let's proceed with example 2. You need to solve the integration of x exponent negative 2x dx. This integral consists of a and e. From Liate, a come first. That's why u is equal to x and dv is equal to exponent negative 2x dx. Differentiate the u, the answer is 1, and integrate the v, the answer is negative exponent negative 2x over 2. Substitute accordingly into the formula and simplify. Then solve the new integral and simplify. You should get negative 1 over 2x exponent negative 2x minus 1 over 4 exponent negative 2x plus c as the final answer. What would happen if we don't use Liate? Now let's take the same example. Integrate x exponent negative 2x dx. Try to reverse the u and dv. Now take u equal to exponent negative 2x and dv as x dx. Differentiate the u, you'll get negative 2 exponent negative 2x, and integrate the dv, you'll get x squared over 2. Substitute accordingly into the formula and simplify. You'll notice that the new integral that you obtain is more complicated than the original integral. Bear in mind, the purpose of integration by part is to replace a difficult integral with the one that is easier to evaluate. Let's refer to example 3. You need to solve the integral of ln x dx. As the integral consists of only one function, which is ln x, you need to assume there is another function which is 1. Now this integral consists of a and L. As L comes first, u is equal to ln x and dv is equal to 1 dx. Differentiate the u, the answer is 1 over x, and integrate the v, the answer is x. Substitute accordingly into the formula and simplify. You should get x ln x minus the integration of 1 dx. Integrate the new integral, you'll get x ln x minus x plus c as the final answer. Take note that integration by parts can be applied twice. The following example illustrates how integration by parts can be applied 2 times. The integral consists of e and t. As t comes first, u is equal to cos x and dv is equal to exponent to x dx. Differentiate the u, you will get negative sine x, and integrate v, you will get 1 over 2 exponent to x. Substitute accordingly into the formula and simplify. You will obtain the new integral exponent to x sine x dx. To solve this integral, you need to apply integration by parts once again. As the integral consists of e and t comes first, u is equal to sine x and dv equal to exponent to x dx. Differentiate the u, the answer is cos x, and integrate the v, the answer is 1 over 2 exponent to x. Then substitute this information into the same formula and simplify. As the new integral is actually the same with the original integral, you can combine them together by moving the integral to the left. Simplify the whole equation. You should get the final answer for the given integral. Make sure you plus your final answer with C. Let's refer to example 5 that is on definite integral. Definite integral refer to an integral that has limit of integration and the answer must be a value. To solve this integral, you need to ignore the given limit and solve the integral as usual. Once you get the solution, substitute the limit inside in order to get the final answer. This integral consists of a and e. So based on Liate, a comes first. So that's why u in this case is equal to x and dv is equal to exponent x dx. Differentiate the u with respect to x, the answer is 1, and integrate the v, the answer is exponent x. Substitute accordingly into the formula and simplify. You should get the answer for the integration of x exponent x dx equal to x exponent x minus exponent x plus c. Next, substitute the given limit into the answer and simplify. You should get 1 as the final answer. Generally, to solve the definite integral, you need to find the answer for indefinite first before you substitute the limit inside. In the next lesson, we will learn the next technique of integration, that is, integration of trigonometric functions. That's all.